So I'm here with my friend Ward Cunningham, who is a remarkable person, the inventor of Wiki, a pioneer of pattern languages of programming and of Agile and Scrum and a number of other innovations, extreme programming. And I thought it would be great, Ward, if we could just talk a little bit about your background and what led you to Christopher Alexander's work in particular. And compare notes on, I know we have a little bit of a common history, which is, in my case, much less experience in computers than you have had, certainly. But I remember programming on the old CDC 6600 mainframe back at the University of Texas back in the early 1970s. And we've come a long way since those days, haven't we?
Yeah, well, you and I have at least a decade of paying attention to each other, and I'm much closer to you than I am to Chris, but I know you're close to Chris, so that makes a one step removed.
A collaborative
group. And it's worked well for me for sure. I wouldn't mind going back a little bit further to my birthday in 1949, which was also the year that EDSAC went online at Cambridge, and that was the first computer that was built just to solve general problems. Problems that hadn't even been anticipated, but they just had that much faith in computers. And a guy named Wilkes added instruction, a subroutine jump, so that they would make subroutines and save them and use in multiple different programs. And that was the first time software programs became a thing that people saved. That people saved and were used and reused and so forth. And I was trying to relate that to the built world, and I think it kind of relates to maybe the time in early agriculture where people finally built a structure and passed it on to their children. And of course that was more than 1949. That was way back there. Right. But that process by which we discover things that are worth keeping, that are really a product of human mind and culture, is something. And of course, computers been moving pretty fast.
Right. 1949 that's your lifetime.
Yeah, that's my lifetime.
And so my lifetime is just a little shorter than that. But so we've had this dizzying pace, and yet we're struggling with the same issue, aren't we? How do we share knowledge? How do we pass down knowledge? How do we refine it?
And that became in, I guess it was the 70s, 20 years after the kind of invention of a program worth keeping, was the work at Xerox PARC, which was very influential to me, and that was Alan Kay and his colleagues just said, we got off on a wrong start, and we need to be much more about computing and programming as a process of thinking and learning. And computers actually became big enough at that time and cheap enough and available enough that, or at least they could see that happening on the horizon, that they wanted to make them for people.
And yet
not for business and governments and armies and stuff like that. And so that was a time of big change, and it was also a time where there was a lot of reflection in computing. It says this computing seems to be getting harder and harder and harder, and the programs are worse and worse and worse, and we need to figure out what we're really working on. Right. And this idea that there was an object inside the program that had properties. And that's when we really started looking for people who were thinking along the same lines, and encountered Chris's work. And it really touched us, because those patterns that he said, well, we looked at the design process and we decided that the reused patterns were more important than the process itself, and that kind of matched what we were thinking in objects.
And it seems to me, this connects to what you were saying earlier about learning and passing down knowledge using language. And I remember I asked Chris once, what's your sort of big takeaway from experiencing patterns and working with this idea of patterns? And he said something really interesting. He said, I thought I was inventing something, but I realized later that I was discovering something. I was discovering how we create modules of knowledge and not only pass them down, but make them able to interact with each other in a language-like way. And I thought that was a very interesting idea. Back to the Xerox PARC thing, I thought it was interesting that the Xerox officials didn't really appreciate what they
had done.
And it took a little young guy named Steve Jobs to snoop around and say, "Hey, this is what we need."
He definitely wanted to put the computers in the hands of every man.
Yeah.
So that of course, even in the research labs there at Xerox, they would say that they invented the word personal computer, and it wasn't brand to marketing for IBM. It was something that you wouldn't think was special to use. Kind of like a telephone. You wouldn't say, I'm going to spend the afternoon, I'm going to make a telephone call.
Right.
I mean, maybe there was a time where you did that, but it wasn't the routine in the 70s. And they said, well, someday it'll be like that for a computer. You'll just use it and you won't think twice about using it. And that was the world they envisioned. Very accessible, I would say. And of course, Chris would say the same sort of things about, who should decide how your house should be, or who should decide what the neighborhood is organized. And it's really the people who live in the house and the people that are your neighbors. And
shouldn't you at least have some control?
When you delegate that completely to somebody else, you get something that's pretty sterile and lifeless. And that's certainly true of computer programs,
and
too.
that's what I find really interesting about your work, is this idea that you want generativity, you want the user to interact and to create new structures with your appliance, not just, okay, here it is, it sits here and you use it. It's this idea, as you put it, that you want to not just specify everything in advance, but you want to find out how to generate and how to give the power of generation to the user. Right?
Well, I was working on integrated circuit design, and I mentioned Alan Kay and computer programming, and Chris Alexander and patterns, and there was also Carver Mead on integrated circuits, and he also emphasized that the people who actually own the problems should know how to arrange the transistors in an integrated circuit to make something. And I was building software to do that using objects. And people looked at my software and they said, well, we're not so interested in how you make integrated circuits. We want to know how you wrote that program. And that's when we really got focused on explaining what we were doing. And I had been really ready to learn that stuff, but I found that a lot of other people had a lot of trouble, and that's when we said, well, what we really need to do is figure out what the patterns are you're going to use, and we just said, well, let's just write them down, and we got about 10 written down, and said, gee, we have so not scratched the surface, we've got to do this as a community effort, and engaged more people in understanding how a pattern, which is like a thing, is, or a part of a thing, but it's not a principle or a method. It's something you actually make.
It's a structure that's out there.
Yeah, and that was a key thing that we learned from Alexander, and we taught people to look for those. And it's made a real effort. I mention it to people here, and they say, "Oh yeah, well that was that old patterns thing." And I say, "Well, I don't know if you've noticed, but people don't actually draw near as many diagrams on the whiteboards anymore, because they'll just say some words, and they're the names of patterns, and then people say, "Oh yeah, those things." Yeah,
it's
sure.
become ingrained in
We've
methodology.
advanced the vocabulary that people use when they write computer programs, so it's had a huge impact. But the other thing that was interesting is that represented kind of concentrated experience. It's not just the mathematics or the
Some
description.
abstraction
No,
of
it's something that It's something,
Something tangible.
that kind of comes out of experience, and until you've had the experience of making things, it's hard to say that there's a pattern there.
That's a very Alexandrian idea too, of
Yeah.
course. And so in the process of sharing these patterns and creating a peer-to-peer network, which is another whole
Yeah,
dimension
yeah.
I want to get into, you created a little something called a wiki.
Yeah.
And I love that story. The story, you want to tell the story of how you picked that name?
Well, I was, I set out, I had a community, and it was people exploring patterns, and we agreed that we wanted to write about what we did in our day-to-day jobs and chop it into little segments. And I built this software at the dawn of the web where you could edit a document right in the browser. And I just started making pages after pages, and I said, boy, this is really quick. I could tell that I was onto something, and I almost called it quick web. But I knew that in Hawaiian that the word wiki meant quick. In fact, wiki means very quick, so I called it wiki web. And I know that because when I first went to Hawaii, I was instructed to take the wiki bus. I said, what? I didn't know that word. I said, it's Hawaiian, it means quick. And so that was my first word of Hawaiian. But what was important about it is it was mundane too. If you're looking at something and you wanted to improve it, you could improve it. And the encyclopedia people came 5 years later and they said, well, this seems to be working for you guys and your computers and patterns. I wonder if it'd work for an encyclopedia. And I said, well, when you're done, you wouldn't have an encyclopedia, you'd have a wiki.
Right.
and
A Wikipedia.
and
as
a
it were.
Wikipedia, and it's pretty fabulous if you think about it. That I mean, I was just looking at it, and there's a nonprofit organization that runs that, and their budget for next year is $93 million.
That's amazing.
$93 million, and that doesn't even pay the people who actually do the work.
Right, because
That pays the people who keep
draw
the
time.
servers running and train people and stuff
Right.
like that. I mean, they,
It's quite a remarkable phenomenon.
80% of that money goes directly to support the construction of the encyclopedia, but most of it is written by ordinary people.
Right.
In fact, if you're an expert, you tend not to fit in as well
Right.
as if you're just an ordinary person, perhaps explaining the work of expert, perhaps explaining the work of other ordinary people. So it's a very, experiential. You get in there, you might have a rough time until you kind of figure out how we work together. And
Very much crowdsource and,
Yeah,
and,
yeah,
and peer-to-peer. And I want to talk about that whole area because there's a strong parallel with Chris Alexander's work there too. And just thinking about how when Wikipedia first started, it was the butt of a lot of jokes, right?
Oh,
It was
yeah.
like, where did you hear that? Wikipedia, ha,
Yeah,
ha, ha.
yeah.
And of course, they're not laughing now.
No,
because
it's
a
a
very
turn-
robust...
Turns out
And-
to be
and
more
yet-
trustworthy than most sources
Well,
on the internet.
Exactly, and while most of the web seems to be getting dumber and dumber and dumber, and you won't believe the 5 stupid
Yeah,
things you'll
yeah.
click on. Number 3 will shock you, and all this kind of clickbait. Wikipedia is moving in another direction. It's getting smarter and smarter and smarter, and I think it goes back to what you were saying about how do we share knowledge, how do we curate knowledge, how do we pass it down. And to me, that's what's exciting about the open source world, the peer-to-peer world, and the idea that certainly in the built environment, the idea that you should get people engaged in sharing with one another their knowledge about how to make their own world better.
Yeah,
Right?
yeah.
That's a very Alexandrian idea, and I think you
Well,
guys-
and he used the term a place that's alive.
Yeah, right.
And I remember he came and spoke to we computer programmers, and it was a very nice keynote, and he's talking about what it meant to have a place that's alive. And then he looked around the conference room auditorium we were in, which could have been a parking garage,
Right.
right? And kind of rolled his eyes like here's an example of a place that's pretty dead,
Right.
and it was livened by having him there, but it was not a place you would choose to be if you didn't have to,
Right.
and that I think. I mean, people get lost in Wikipedia too. They just don't want to leave. They say, "Well, I came here looking for something, but I found 15 other
Yeah,
interesting
sure.
things."
Yeah, right.
And part of that is because the whole process of creating and editing and whatever has ordinary people involved.
Right.
It's people making that for other people instead of some computer algorithm or some scheming entrepreneur or something like that.
It's literally a living process. That's going on.
And it's it wants everything in there to be notable in the sense that you would expect of an encyclopedia, and you have to cite your sources. But other than that, it's it's driven by people's desire to write things down.
Right. Well, and I think this idea that when people can come together and create in a peer-to-peer way, if the process is curated, if there's a way of making sure that the knowledge grows and gets richer over time, then the result of that is that everybody is more effective in what they do, and it doesn't make things more complicated. That's what's interesting. The web is making everything noisier and more complicated, and who do you believe? There's a he said, she said, and yet the end result of this kind of curation process is sometimes things get much simpler and easier to understand. I mean, I noticed, for example, you've talked a lot about trying to find what you call the simplest thing that could possibly work.
Yes.
Right? How do you just get down to the essence of what matters in a given relationship and focus on that? And that's a big part of your work.
When we were kind of learning how to use this new object-oriented programming, and that was 20 years ago now, but we would struggle with, is it going to be hard to write this program, or is it going to be easy to write this program? And we'd be thinking about the end result, where we were trying to go, but we couldn't really see all the steps, and we'd get stuck. But we're working together, and I would just turn to my colleague and I'd say, I think we're making this too hard. What's the simplest thing that could possibly work?
Yeah.
Let's not worry about whether it's right or wrong. Let's see something work.
Yeah.
And then we would write a program that was so simple-minded that if it worked, it would only work in one case. But then we saw it worked, and we said, oh, well, here's how to add another case, and here's how to add another case. We made something work, and then we grew that to something that worked better. And if we couldn't do that, then we knew there was a wrong step. But, I remember Alexander again, we'd be talking about how he'd say, well, nice thing about building with bricks is you can build the wall up to about the height of the window and walk around the room
and decide
where the
one.
window should
Exactly.
be. Right.
And
You don't
adapt.
have to
You can
decide where the
adapt.
window should be. You build with studs, and you better have the studs not in the
right.
center of a window. And that architectural approach that lets you learn something important about a big project by taking small steps that aren't invalidated as you get further down the road. That you aren't forced to make decisions that you don't have to make. And of course, in software, you can pretty much do anything in any order. You can, if you want to. There's no basement that holds everything up. There's a thing here and a thing here, and they talk to each other. And if you do this one before this one, well, you kind of fake this one out.
It's an iterative process.
Right, or if you do this one first, you fake this out. There's something you can do with pretty much everything you write, and that is one reason why I think we've been able to see patterns and apply patterns and reap the benefit of patterns faster in software. Just the fact that this whole development has been in my lifetime instead of, our species' lifetime is indicative of that amazing power of the computer. But it is also amazingly possible to abuse.
Yeah, it can go awry. And,
The fact that all the biggest companies today are software companies.
Right.
And
we have this huge backlash against their power, the power that they have,
and it's kind of like we have an economy that favors scale.
Right.
And I know Chris has railed against this too. That's why we have big boxes instead of charming neighborhoods.
Well, we've
But-
talked about the idea that nature does use economies of scale and standardization, but it also uses economies of place and
Yeah.
differentiation.
Yes.
And it seems to me that's what you're really adding to the mix when we're talking about software and when we're talking about technology more broadly. How do you get that adaptation, that ability to just take the next step, the next simplest possible thing, and make it better?
And of course,
better
if
and
I
better?
write a program for a computer that fits in my hand, there was a lot of supply chain that had to make that computer that fits in your hand. You know,
Sure.
I can't condemn every industrial operation
Right.
because they supply me with
Right.
pretty great computers. But when you get into this software, what are you going to make them do? What are
Right.
the routines going to be? Going back to Wilkes and the subroutine call, then having a much tighter cycle, more people in the loop, more variety, turns out to domesticate, if we could use those words, those handheld computers, and make them something that
Make them more
that-
adaptive
yeah,
and
that
more
lives.
useful ultimately in the
world.
process rather than just something that dictates the process.
So I encourage people. I work on an architecture team here, and we encourage people to really embrace our fellow employees as a learning exercise.
And
You know,
that
they
software
would-
architecture,
Right.
of course, yeah.
But by the same time, I'm quick to share that I do as much learning as I do at work. I learn as much at home developing open source software.
Sure.
And in open source software, I have much more freedom to pursue something that delights me instead of delights a customer. That's fairly abstract. And what I learn in one supplements the other. So I carry ideas back and forth. And so I think this idea of making sure, I mean, you know, we need to work within the economy because that's,
Right.
you know, just what we have to do. But
Right.
but stepping outside of that economy and not thinking that everything has to be for an immediate monetary reward,
Right.
but you know, that is somehow participating in a community or culture that is that wouldn't be possible without, you know, you and many others doing the same thing. That
Right.
is important. It's been important
Yeah,
to me, and it's, you know, going back to the time I first read Alexander, and I said, well, you know, this looks a little like a building code book, but it's got a lot more
There's
going
something
on.
else going on.
A lot
I
more
think
going
it's
on there than
remarkable that you and your colleagues saw that, and many of my colleagues, frankly, haven't really picked up on some of the deeper significance there. But the other thing is, we've talked a lot about this whole relationship between open source and proprietary, and the fact that actually you need both, and you
Yeah.
need a sort of healthy ecology. Sometimes the problems that we have, it seems to me, are when the proprietary tends to get too big and out of scale, and maybe we're seeing some of that in the tech world right now. But it seems to me also that this whole culture of what's outside of the proprietary and complementary in some ways. I mean,
Yes.
for example, Linux is widely considered the most powerful operating system, right? And it's an open source operating system. So,
and it was not born that way.
Right.
It was born as kind of a simple clone of something
Unix, right?
already
Yeah.
widely available.
Right.
But because there are so many people who contribute at every different level, it actually is much more responsive to the need for change. But it also, in a strange way, as people who are contributing their effort find that their effort is harder than it should be, they'll go change that foundation to make it easier to contribute to. And so it actually becomes, I like to think of, sculpting in clay. If you can feel the clay and the clay feels good and you can push on it and things happen, then you can work that clay. And it's an artistic medium. But if
It
it's,
responds to
but
you
if
in
it's,
real time.
But if it's
Yeah.
stiff and lumpy or cracks or whatever, if it's not a good material, then maybe with enough effort you can make something out of it, but it's not like it's an easy expression of your own.
I think that's a good analogy of a problem we have with technology.
Well, I think
now.
for,
It's too
for,
lumpy.
sure, for sure, because
Yeah.
the idea that you would take a computer program that you spent half a year developing, and then you realize it's kind of lumpy, and you say, well, let's just take the lumps out, and some manager's just going to say, well, is that going to make us more money?
Right, exactly. Right.
And, well, not this week. It'll probably make us less money
Right.
because we're not adding a feature we can sell, but we're investing in our own ability to express our creativity.
Yeah.
And boy, certainly in our field, and I think the built world too. That there's plenty of change forced upon us due to growth and limits of resources and stuff like that. Both the computer could benefit from a lot of rethinking about what it's really there to do, and cities could use a lot of rethinking about what cities are really there to do.
And I think we, in the city-making fields, urban design, architecture, urban planning, we have to think more deeply about how to create value in a way that might not be reflected in the economic and the proprietary systems. Or maybe not today, but maybe we need to figure out how to make it more rewarding later on, because ultimately you may need to make sure that these companies stay in business. So that's a huge part of our work these days, is thinking about externalities and how do you bring those back into the process, and thinking about that.
And I'll tell you, we've taught economists a thing or two about creating value. They're saying, well, we can prove with formulas that Linux or Wikipedia just can't work.
Right, exactly.
And they say, well, darn, it does work,
Exactly.
And they say, well, maybe there's something missing in these
I
formulas.
think that's a huge topic that needs more careful study by economists. You're absolutely right about that. The whole sort of the open source economy, and there's been a lot of discussion about the gift economy and so on. I think that's a little simplistic. There's more to it than that.
It's more to it.
And also, how do as I said, how do the proprietary and the open source fit together in a certain kind of ecology? Is an interesting question. But another thing I want to turn to, since especially with our program that we have in Sorrento, Italy, called Building Beauty, which is a course that is reflecting Chris Alexander's work and taking some people from the built environment, thinking about how processes can create more. In their case, they're describing it as beauty, but I think you could describe it more broadly as life, as things that we find beautiful and restorative and important to us in our lives, not just the superficial aesthetics, but the sort of deeper, like mathematicians talk about beauty in the formula, and you talk about beauty in the software and the code. So how do you think about coding beauty, if you will? What does that phrase mean to you, and what do you see in your own work and in the work that you've picked up from Alexander?
Well, there's kind of two parts to it. There's certainly when you're done and you hand your software over to people that you wrote it for, and they say, I like it or I hate it. They're responding to, in some sense, its utility to them.
Right.
And if they find that they can find a way to get it to work, but they hate using it that way, it might have the utility, but it doesn't have beauty. It doesn't seem natural to just solve your problems. And that's understanding how to make software that works like that. But I'm also interested in the you make some software and you discover it needs to do a little more. If software is successful, of course people will want it to do more. Only time they stop wanting is when they've decided they hate it.
Right.
So what does it have to be like? Going back to this idea of clay, it doesn't look like clay. It looks like some of the most incredibly complicated descriptions. It's a little mathematical, lots of symbols and stuff like that, pages after pages. But when you get to looking through it and you read it, and you read that stuff all day long, you see things in there that just look right, that look powerful, that look like, if I have to work here, I'm going to enjoy my day.
To have this great fit to them, and this great sort of
and that is,
order to them.
It's a sense of beauty much like the mathematician, you'd look at a bunch of squiggles on a
Right.
piece of paper and it says, "That's beautiful."
Exactly, yeah.
You know, maybe
There's
the
a
penmanship is
symmetry
pretty
there.
nice, but no, there's something about what the symbols mean
The order, the
that
order
is
that's there,
beautiful.
yeah.
And we see that in computer programming, and it's very common that people with a few years or more of experience will observe that,
Yeah.
but they have trouble explaining that to their management. And they say, well, the program's not looking too good, or not feeling too good, or it has some smells in it, which I can't quite identify, but I
Right.
know there's something
Right.
wrong in there, just like the fridge. When
ugly.
the fridge
It's
starts to
ugly.
smell,
Yeah, right.
you know, you don't know
Right.
what it is
Right.
until you get to looking. But that's not seen as something that's important, because that's really working on it to make it better for you. Now, if it's
for
better
your
for you,
well-being, right?
well, it's going to be better for your customer a month from now,
Yeah, right.
when something comes up and you can say, sure, we can
Yeah.
do that, instead of, no, too hard, didn't
Right.
think about it, didn't ask for it in the beginning, so you can't get it now.
Right.
That kind of
Rigidity.
yeah, and so keeping that in a computer program, well, that's, you know, it's something that you can feel it. You can't be a programmer and not feel it, but it's very hard to explain to other people. You know, I suppose, glider pilots sometimes say, well, you know, they have experience flying that they can't explain to anybody
Yeah,
else that
right.
doesn't fly.
Right.
And I think, or dancing.
Right.
You know, something
right.
like that, just using your body
Right.
in some way, you can say, well, that's beautiful. And you know, it might just look like bouncing around if you weren't familiar with, you know, the physical motion of dancing.
And you were talking about this earlier, the idea that it comes out of your own experience and your own sort of being grounded in the place.
Yeah,
And students in Sorrento are actually doing things like, you know, building actual parts of their landscape and gardening and, you know, things that are just helping to ground them a little more physically, because I can tell you, as having gone through architecture school myself, it can become very cerebral, very abstract, and you have all these sort of castles in the sky that don't have any real relationship to human life. And I think one of the things we're trying to confront is, how do we create a more grounded approach to architectural education to give people more of a hands-on sense of why it means something to you, why it's beautiful to you, why it, you know, has this quality that's very hard to express. Chris called it the quality without a name, in fact. And then I love the fact that the software, some of the other software programmers refer to it as Quan.
Quan.
QWN.
Yeah, they're so used
they
to
named it.
Yeah.
They named the quality without a name. But
Yeah.
but that's the idea that, as you're saying, that there's things about experience that are fundamental to experience, and we're only abstractly referring to those when we use language and symbols and processes and so on. And we have to be very careful not to get caught up in those abstractions and remember to stay grounded.
Yeah.
So on that note, that's probably a good time to
Good time to stop, you know.
And thank you.